Hey, how you doing? In today's lecture, we'll talk about jaundice. Let's get started. We'll discuss this topic under the following subheadings: fate of RBCs, the introduction to jaundice, the types of jaundice, the test for jaundice, that is the Vandenberg test, and the concept of neonatal jaundice. Now, before we actually start with jaundice, about the concepts of bilirubin and the raised levels, we need to know how bilirubin is formed, from where it comes, and how its levels can be raised. Okay, so that can be explained by this diagram here. Now, let me just give you a brief outline of this diagram. This is a blood vessel, and this is an old RBC. Now, if you remember, the lifespan of an RBC is about 120 days, right? So after 120 days, there are certain changes that take place in the membrane of the RBC. In the membrane of the RBC, certain changes takes place which make the RBCs more fragile. So when it passes through the minute capillaries of these three structures, spleen, liver and bone marrow, these three structures together form the reticuloendothelial system. Okay, spleen also known as the graveyard of the RBCs, right? Because most of the RBC destruction takes place in the spleen. Okay, so when the old RBC enters the minute capillaries in the blood vessels in these organs, it cannot pass through them because it is more fragile, right? The red cell membrane loses its flexibility. Okay, so then it gets destroyed. How it gets destroyed? That is, lining or surrounding these membranes, right? Surrounding these membranes are present macrophages. Now, the macrophages in the spleen are present in the cords of Billroth. Macrophages in the liver are known as Kupffer cells, and macrophages in the bone marrow are called littoral cells. Okay, so these are just the different names that have been given to the macrophages. So this is a macrophage. Now, what happens is that we're talking about the fate of RBCs. Okay, so when the RBC membrane is fragile, it breaks open and releases hemoglobin. This hemoglobin is taken up by these macrophages. So hemoglobin, it enters the macrophage. Now, as hemoglobin enters the macrophage, it is split into two components, heme and globin. Now, globin, being a protein part, can be degraded into its various amino acids, and the amino acids can undergo their respective metabolisms. Okay, coming to heme. Now, heme is an important precursor of bilirubin, right? Heme will ultimately form bilirubin. Now, what happens here is that heme is subjected to an enzyme called heme oxygenase. Heme oxygenase to form biliverdin. Okay, to form biliverdin. Now, biliverdin undergoes reduction reaction to form bilirubin, and the enzyme is biliverdin reductase. Here the enzyme is heme oxygenase, and here the enzyme is biliverdin reductase. Okay, so bilirubin has been formed. Now what happens is that this bilirubin is released from the macrophages into the blood. Alright, clear till now? Very easy. Hemoglobin is taken up, broken into heme and globin. Heme is converted to biliverdin and then to bilirubin. Bilirubin is then released into the blood, into the circulation. Now, in the blood is present albumin. As we all know, blood has plasma proteins, and the major plasma protein is albumin. So what this bilirubin will do, it will bind with this albumin, and this albumin bilirubin complex, okay, this is the albumin and this here is the bound bilirubin. So the albumin bilirubin complex will travel and reach the liver. In the liver, what happens is that there are present hepatocytes. In the liver there are hepatocytes, right? There are multiple millions of hepatocytes present. So what they do is they take up only bilirubin. Only bilirubin is taken up, and albumin is released back into the circulation. Remember, albumin bilirubin complex travels in the blood, reaches the liver where only bilirubin is taken up and albumin is released back into the circulation. Now an important point here is that this bilirubin that is present here is known as unconjugated bilirubin. Unconjugated bilirubin. Alright, it is known as unconjugated bilirubin in the blood vessel before it reaches the liver. Conjugation takes place in the liver. You need to remember this fact, right? Conjugation takes place in the liver. So any bilirubin that is present before the level of the liver, that is here in the blood vessels, is unconjugated bilirubin. Now what happens in the liver? Conjugation. Bilirubin combines with UDP glucuronic acid. It combines with, I'll write it here, UDP glucuronic acid. Bilirubin combines with UDP glucuronic acid to form bilirubin diglucuronide. Bilirubin diglucuronide. Now this form is the conjugated bilirubin. Okay, the conjugation has occurred. What do you mean by conjugation? Conjugation means any substance, for example here it is bilirubin, any substance combines with a conjugating agent. Conjugation is a type of detoxification which you study under the heading of detoxification biochemistry. So for now you just need to remember that bilirubin comes and combines with a substance, and this process is known as conjugation. The substance is UDP glucuronic acid and the product form is bilirubin diglucuronide. Okay, now what happens is that this is released into the bile, and this release is an active process. It requires ATP. Okay, bilirubin diglucuronide or conjugated bilirubin is released into the bile, and from the bile it travels and reaches into the intestine. As we all know, the bile duct opens into the second part of the duodenum, right? So bile duct will open into the second part of the duodenum, from where the bile will reach to the small intestine. Terminal parts of ileum and the large intestine are the main sites where the further mechanisms will occur. Now what happens here, that we have bilirubin here, right, or bilirubin diglucuronide is present here. Bilirubin diglucuronide, write it properly, it is bilirubin diglucuronide. Now there is an enzyme called glucuronidase. Alright, glucuronidase, right? This will convert the conjugated bilirubin into urobilinogen. Alright, urobilinogen is a colorless compound. So what happens? Conjugated bilirubin or bilirubin diglucuronide enters the intestines, especially the terminal ileum and the large intestine, where glucuronidase enzyme is present, which converts the conjugated bilirubin into urobilinogen. Now what happens, that some part of urobilinogen escapes into circulation, right? It escapes into circulation. Alright, the remaining part of urobilinogen is excreted via the kidneys in the urine. If it is excreted in the urine, it is changed to a yellow colored compound called urobilin, and urobilin is the reason why urine is yellow colored normally. Okay, urobilinogen is broken down or it is converted to urobilin when it is excreted in the urine. When it is excreted in the feces, the urobilinogen is converted to stercobilin, which is responsible for the color of the feces. And urobilinogen to stercobilin is done by the action of the intestinal bacteria that are present. Alright. Now another point to note here is that while traveling in the bile duct, what happens is some amount of bilirubin also escapes into the circulation. Alright. This forms the serum bilirubin that is conjugated, and some part of it is excreted in the urine via urine as urine bilirubin, right? So in urine you may find urine bilirubin and you may find urobilin, both. Okay, and in feces what you find is stercobilin. So this is the fate of RBCs, or basically the fate of hemoglobin. This was needed to form the basis of jaundice, because now we can understand when we say conjugated bilirubin, when we say unconjugated bilirubin, when we use the terms urobilinogen, urobilin, stercobilin. So all these should be clear. What do they mean and where do they come from, right? So now we'll move on to the introduction of jaundice. Now that we've already seen the normal mechanism of heme and how bilirubin is formed, let's go and see what jaundice is. Okay, first we need to know the normal serum bilirubin levels. The normal levels of total serum bilirubin is 0.2 to 1 milligrams per deciliter. Total means conjugated as well as unconjugated. We've already seen what unconjugated means and what conjugated means. So total level is 0.2 to 1 milligrams per deciliter. Serum conjugated bilirubin, the conjugated part out of the total, is about 0.2 to 0.4 milligrams per deciliter, and serum unconjugated is 0.2 to 0.6 milligram per deciliter, right? These are the normal levels. Now whenever bilirubin levels rise above the normal levels, we say there is jaundice. Now to clinically detect jaundice, we say that the person shows yellow discoloration of skin, sclera and mucous membrane. Skin is the normal skin, sclera in the eyes, the white portion of the eyes, and the mucous membrane that we see like the conjunctiva. Okay, so these areas show yellow discoloration because of raised serum bilirubin levels. Okay, so we say that yellowish discoloration starts or is clinically seen only when serum bilirubin levels are above 2 to 3 milligrams per deciliter. Normally they are below 1 milligram per deciliter. Whenever they rise above 2 to 3 milligrams per deciliter, there is yellow discoloration, and we say that the person is suffering from jaundice. Now jaundice per se is not a disease. It is rather considered to be a symptom. Right? The patient says कि मुझे पीलिया हो गया है. So that means that the person is suffering from jaundice. Jaundice always has an underlying cause, which is the main disease. Right? Jaundice is just a symptom of that disease. Right? Now before we actually go into the types of jaundice and their different details, just let me quickly tell you about a specific test called Vandenberg's test that we do to detect the increased levels of bilirubin in the serum, and it also helps us to differentiate and distinguish between the two different types of bilirubin, that is conjugated and unconjugated. What we do here is we take, say this is a test tube. In a test tube we take the patient's serum sample. Okay, and here what we have is diazo reagent. Diazo reagent consists of sulfanilic acid in concentrated hydrochloride acid. Concentrated HCl plus sulfanilic acid is called diazo reagent. It also has sodium nitrite in it. Okay, so that is the composition. Not really required, but if you remember it, well and good. So what we do is that we put the diazo reagent into the serum. Now when we put this diazo reagent into the serum, it may result in three mechanisms, or three results can be obtained. Number one, the first result is that within 30 seconds, in less than 30 seconds, we see a purple color in the serum. The serum shows purple color. So this means that there is presence of conjugated bilirubin. Now you need to remember that conjugated bilirubin is soluble bilirubin. Okay, and diazo reagent reacts only with soluble bilirubin. Will you remember this? Conjugated bilirubin is soluble bilirubin, and diazo reagent reacts only with soluble bilirubin. So if soluble bilirubin is present, there is formation of a purple colored compound. Alright. The next type of reaction, if soluble bilirubin is not present and insoluble bilirubin is present, diazo reagent will not give any color. There will be no color change. However, if you add methanol, there will be, on addition of methanol, what you will get is a purple color. Now what does methanol do? Methanol is a solubilizer. The insoluble bilirubin will become soluble when you add methanol and will react with diazo reagent to give a purple colored compound. Okay. The third point is that it gives a purple colored compound initially, but when you add methanol, the purple color intensifies. right, it becomes more purple, it becomes more deep and more dark. This type of reaction is known as biphasic reaction. Alright, we'll see in details, we'll relate this entire test to the different types of jaundice. Now there are 3 tests and each of these tests is given in a particular type of jaundice, right? So we'll link which test is given in which type of jaundice as we see the different types of jaundice here. So this is the basis of the Van den Bergh test, that a diazo reagent is added to the serum, and based on the type of bilirubin present, it will give different reactions. Okay. Before I actually go, just one little thing for you to remember. We saw in the previous diagram that this is the blood vessel, right, which has the unconjugated bilirubin. Here there is present unconjugated bilirubin, right? In the liver, unconjugated gets converted to conjugated. So in the liver, if we see, there is presence of unconjugated as well as conjugated bilirubin. And when it is excreted in the bile we've seen that there is presence of only conjugated bilirubin. Right? Now this little concept is very important, and based on this concept you can understand this entire table and remember this very easily. Again, the blood vessel or the blood or circulation before liver contains unconjugated bilirubin. In the liver is present unconjugated as well as conjugated. It's common sense, right? Liver is the site of conjugation. So it has to have both unconjugated and the converted product that is conjugated, right? And then it releases it into the bile through the bile duct, which has only conjugated. Okay? So it's very simple that before liver it is unconjugated, in the liver there is both, and after liver there is only conjugated. Now coming to the different types of jaundice. The different types of jaundice are prehepatic, hepatic and posthepatic. Prehepatic means that the cause or the underlying cause of jaundice is before the liver. If you come to this diagram here, we can see that the cause before the liver is blood. Alright, before the liver, what is the cause? Blood, right? So we say that this type of jaundice is prehepatic or hemolytic jaundice. Blood shows hemolysis, means increased RBC breakdown. That is hemolysis. It is common sense. When there is increased RBC breakdown, increased hemoglobin will be released, right? If increased hemoglobin is released, increased heme is generated in the macrophages and increased bilirubin is produced, right? And raised bilirubin is jaundice. So we come here and we say that the main cause or the main reason of prehepatic jaundice is increased RBC breakdown, also known as hemolysis. Therefore, this type of a jaundice is also known as hemolytic jaundice. Prehepatic jaundice is also known as hemolytic jaundice. Okay. Moving on to the second type, that is hepatic jaundice. As the name suggests, there is problem in the liver. Right? There is some pathology or some infection or some toxin that has damaged the hepatocytes and has made them incapable of conjugation. Right? So there is damage in the liver. So we say that hepatic jaundice is mainly caused due to infective or toxic liver damage. Therefore, this type of jaundice is also known as hepatocellular jaundice. Hepatocellular jaundice. Because the hepatocytes, the hepatic cells are damaged, right? Coming to the third type of jaundice, that is after the liver. It's very simple. One is before the liver, one is liver itself, one is after the liver, right? Now, what can happen after the liver? You may think that there is some damage to the bile ducts carrying the bile. No, there's no damage as such. But what we say, what we clinically consider is that there is an obstruction here to bile flow. Bile cannot flow freely. Right, the bile has moved out of the liver, but somewhere along the bile duct, somewhere along the path, the bile cannot flow into the intestine, it cannot reach the intestine, there is some obstruction. Therefore, post-hepatic jaundice is also known as obstructive jaundice. Obstructive jaundice, right? There is some obstruction in the biliary tree. So, repeating it once again, prehepatic jaundice is also known as hemolytic jaundice because it is caused mainly due to increased hemolysis or increased RBC breakdown. The concept behind this is that there is increased RBC breakdown, increased release of hemoglobin, increased conversion of heme to bilirubin. In hepatic jaundice, there is infective or toxic liver damage, also known as hepatocellular jaundice. Therefore, the conjugation is affected. And the third type of jaundice is known as post-hepatic or obstructive jaundice, because there is obstruction to the bile flow in the biliary tree. Okay, very simple. Alright, that's it from this video. I hope it made sense. I hope you understand. You can go back to your books and read it. It'll definitely make sense and it'll definitely be easier. I'll see you in the next one.